right, we're going to add to the derivative section today. We're going to hit 2 rules. All right, and we're going to work really hard at these theorems today. So I'm in the derivative section. Okay. We're just going to, I already wrote it from the previous periods. We're just going to talk it out, but let's take our time here. We're going to tackle the first and second fundamental theorems. So in the derivative section, green. Okay. So first fundamental theorem says if I integrate from a to b of little f of x dx, I have to get somebody else. So if I integrate little f, I have to get big F, and it's always upper minus lower. So I should get big F of b minus big F of a. Okay, so just yesterday in the non-calculator section, there was 4 of these on the test we took. Okay, and then in the calculator section, there was 2 more. This is a huge theorem. The other way to think of it is a want equation. Okay, it's the same equation, just rewritten. And most of the time, you see me writing it like this. So what I want would be f of a equals the initial f of b. And then I keep saying these 2 numbers have to be the same. So it's the initial amount is my lower bound. Even if they're backwards, you have to write it this way first. Initial to want of f of x dx. So first fundamental theorem. Okay, huge, absolutely huge. Bless you. All right, the second one obviously is called the second fundamental theorem. And this is when you take the derivative of an integral. Okay, there is at least 1 in every multiple choice, and then 1 free response will most likely be devoted to this theorem. So when you take the derivative of an integral, it's all about the upper bound. You substitute in the upper bound. So I'm just replacing my x with t, and then I multiply by the derivative of the upper bound. And then let's just write those 2 things down. First, plug in the upper bound. And then second, multiply by the derivative of the upper bound. So when you say second fundamental, second is the number 2, you should be thinking there's 2 things I have to do. Plug in the upper bound, multiply by the derivative of the upper bound. Okay, and like I said, for some reason, so you've seen 2 practice exams so far. They say they go in order of increasing difficulty. Now, whether that's your belief or not, that's what they tell us. So really, the first 10 questions should be the easiest in the packet. They always stick this second fundamental at the end. I don't know why. I don't usually think it's a difficult question, but you'll see this towards the end. So now that you kind of got a feel for the exam, when you go to take the next one, look for that easy question. It should probably be towards the end of the multiple choice. And like I said, you'll have 1 free response mostly devoted completely to the second fundamental, and we'll just keep throwing those on spirals. I'll put another one on there this week. All right, so we're focusing literally on those 2 things today. So in your packet, the College Board actually put this together. They said this is such a big deal. They wanted everyone to go over it. It's a special focus on the 2 fundamental theorems. So I'm going to pull out just the ones that deal with the first. We're going to start with all first fundamental questions. So I think the first one on there is number 3. I'm just going to put a first. Okay. So again, this is a first fundamental. So I'll give you a minute to read it. It's a little old. It's from 1973. I believe the exam started in the 60s, actually. It's been around a while. Way before my time. I just want to be clear about that. And this should be one nobody misses. All right, so this key here, what are they telling you little f is the same thing as? Big F prime, right? So I'm going to rewrite that integral as big F prime. They're telling you it's the exact same. They're telling you it for a reason. Okay, so if I'm really integrating big F prime, who should I be getting? Big F. And who should go in first? Big F of B minus big F of A. Obviously, you cannot get the same thing. You have to get somebody different when you integrate. And they're telling you those are equivalent. So I just rewrote it and integrated. So it should be choice D. Okay. Now, obviously, I want you to think about these on your own. I don't want to do everyone for you. So I'm going to list out, go through and circle these questions here. I'm going to put them up here. These are all the ones that deal with the first fundamentals. I want you to circle those, and then we're going to, on your own, attack those for a good 10 minutes. These are all first fundamentals. All right, and I'm going to interrupt you one more time. I'm just going to look at question 27. Everyone look up here so I don't have to say this 10 times. Just look right up here. This is the year it happened. This was the exam. Don't worry about that. This is the number of the test. Anything greater than 40 is calculator active. So just keep that in mind. If this number is greater than 40 on the questions you're doing, it's a calculator question. So have your calculator handy. Take a peek at that end number. If it's greater than 40, use your calculator. If it's not, don't use your calculator. Greater than 40. All right, let's regroup here. We'll talk about any that we need to. I'm going to start on 6. So flip back to 6. Okay. So again, these are obviously all exam questions, so we would expect to see wording the same way. Very typical questions, and we just focused on first fundamental. So f is continuous. If I integrate f prime, who should I be getting? F. And then again, you're plugging in upper minus lower. So again, doesn't make sense, doesn't make sense, doesn't make sense, doesn't make sense. Should be choice A. 11. Okay, so the graph of f is shown, and the integral from 1 to 3 of f of x is 2.3. So again, what does the integral represent? The area. So they're telling you the area from 1 to 3, this section has an area of 2.3. And then they tell you, so this is a graph of f, it says, f is equivalent to big F prime. So I'm just going to say it's equal to big F prime. Okay, but here's what they want. They want f of 3 minus f of 0. What is the only way I get f of 3 minus f of 0 if I do what? Integrate from 0 to 3. If I want f, who am I integrating? F prime. So this is the first fundamental that every paper should have. If I want f of 3 minus f of 0, I should have integrated f prime from 0 to 3. So if that formula isn't on your paper, put it on your paper, because that's the whole goal today, is to get this first fundamental down. Okay. So again, the integral represents the area under the curve, and this is f prime. I know the area from 1 to 3. Could I figure it out from 0 to 3? Sure, this is just a rectangle. What's its area? 2, so this whole area is 4.3. But again, just write out the first fundamental, and you've got it. Use the little keys. 14. Again, initial condition. Want. Okay, every paper should have the same formula written down. I want f of 4. Who should I be writing next? F of who? F of 1. Plus, that means these bounds have to be the same. The integral from 1 to 4 If I want f, I'm integrating f prime, and f is the antiderivative of this, so this is who I'm integrating. But every paper should have that written down. My want equals the initial plus initial to 1. Now before I go to type it in, I'm going to say, okay, f of 1 is 0. That's my second step, plus this integral. And then throw it in your calculator. What did we end up getting? 0.37. Does D sound right? Okay. But again, that should be on every paper. 15. The flow of oil in barrels per hour. Barrels per hour. Throws through a pipeline is given by the graph. Which of the following best approximates the oil that have passed through the pipeline that day? So I want the number of barrels. So again, I should have an equation written down. If I'm going from barrels per hour to barrels, I should be doing what to this function? Integrating. And it said for the first day, so from 0 to 24, I'm just going to call it B of t. I don't know what its name is. dt. Okay. There's no initial condition, so I don't really have to add anything on there. And again, what does an integral represent? The what? I just need to figure out this area. Now, there's a calculus way, and then I think there's just like a third grade way. Right? The common sense, the third grade way. And if I want the area under this curve, they all happen to be what shapes here? Really close. Rectangles. How big is each area? Each square? 600. So first of all of this area has to be greater than what two choices can I eliminate? 5 and 600 don't make any sense because one block is 600. How many of that? Right here I have a total of how many? 2,400, which there's still more than that, so it obviously has to be D or E. I would say that's kind of like almost half a block. So if I was just a gambling woman here, I would say that makes about a block, and I would have approximately how much? Roughly 3,000. Okay. If I wanted 4,800, I would have to have 6 times how many? 6 times 8 blocks. I definitely don't have 8 blocks, right? Now, what's the calculus way? Since again, that was kind of like the third grade way, think it through. What can I use to represent the area? I could use, what did we always draw in here? A Riemann sum. Who's the most accurate Riemann sum? Trapezoid. You could do quick trapezoids, and that's going to get you a much better approximation than the third grade way. But these were so spaced out that was just a simple arithmetic method we could go with. But again, I would say 1/2 base height 1 plus height 2 if these numbers were much closer together. Okay. And again, I think I've seen this 3 or 4 times on these exams. Fairly common question. Don't be afraid to go kind of the third grade method on it. You're just approximating that area. 16. Okay, what do they tell us about F? Everyone underline that. That's going to answer the whole question. Okay. Now let's finish our first fundamental. If I integrate F double prime, who am I getting? F prime of B minus F prime of A. Okay, so finish the first fundamental. Now, they told you something about F. They told you that it's linear. Draw your favorite linear function. Everybody pick one and draw one. Draw a linear function. Someplace on that linear function, plot A and plot B. Okay, and we could all have different pictures, that's fine, but if it's linear, we're all going to get the same answer. Plot A and plot B. Could be, doesn't have to be. What are we looking at, though? We're looking at what of B and A? Compare those slopes. What are they? They're the same because it's a line. So if I take the same number minus the same number, I should always get 0 because it's linear. So I drew my linear function like this. I put my A here, my B here. The slopes are the same. Therefore, I'm going to get 0. Okay, if you drew it this way, the slopes are still the same. Because it's linear, you're going to get 0. 18. Again, I have an initial condition and a want. First fundamental staring right at us. Every paper should say the same thing. F of 9 equals F of 1 plus the integral. I'm going to put a bracket there so I remember. From 1 to 9. I never care if those bounds are backwards. You have to follow the rule. And I'm integrating this function, ln of x cubed over x dx. They keep giving us 0. That's way too nice. 0 plus that integral. I don't remember what I got. C sound right? Okay. So again, first fundamental, over and over and over. 20, no different. They gave us an initial and a want. So every paper should have the same thing. I want f of 1, so I have to start with f of 0 plus the integral. Those should be the same from 0 to 1. Now if I want f, who should I be integrating? F prime. Okay. Again, it's the same question over and over. So I know f of 0 is 5. How am I going to find the integral of f prime if I'm given a graph of f prime? Find the area. What shape is it? Triangle. So it's just 1/2 base times height. That should have an area of 3 for a nice easy 8. Okay. But again, doesn't go away. That was on our practice exam, I think. 22. They threw a lot of information at you. A pizza is heated to a temperature of 350 degrees. It's taken out of the oven and placed in a room 75 degrees at t equals 0. The temperature of the pizza changes at this rate. Circle those units for yourself. Degrees Fahrenheit per minute. To the nearest degree. How am I going to go from degrees Fahrenheit per minute to a degree? Integrate the temperature of the pizza. So I want to integrate because I want Fahrenheit. I want the temperature of the pizza. So I'm going to integrate from 0 to 5 of this negative 110 e to the negative 0.4 t. So what I get will be the change in the temperature of the pizza. Change in the temperature of the pizza. So go ahead and integrate that. I don't know what that is off the top of my head. I don't have my calculator anymore. Just this integral. Yeah, I know. Someone plug that in for me. Thank you. Okay, now notice that's not a choice, but they did take that negative and make it a positive to try to trick your brain. This is saying the pizza's changing this many degrees. Well, how many degrees did your pizza start at? Started at 350, and obviously if you put your pizza out of the oven, it's going to start to cool. I should take that 350 and add, well, I actually want to add that number on, because if I subtracted it would get larger. Add that integral on. Okay, so 350 minus that answer, or plus that answer, should get me, does 112 sound right? Okay. Did the 75 have anything to do with it? No, that had nothing to do with the temperature of the pizza, and that's what the question was about. 23. Particle moves along the x-axis, given its acceleration. If the velocity is 2 when time is 1, so there's an initial condition, what is the velocity when the particle, then the velocity of the particle at time t equals 2 is what? Okay, so I want the velocity at 2. Who do I have to start with? V of 1. Plus the integral from, those have to be the same, from 1 to 2. If I want velocity, I should be integrating a of t. And again, every setup should be the same. That should be a super simple question. What can I put in place of v of 1 now? 2. But I'm not doing that first. Write out the equation first, and then throw it in your calculator. What do we get for that answer? E is correct. And again, first fundamental over and over and over. 27. Insects destroyed a crop in tons per day. Highlight that. Tons per day. To the nearest ton. You want tons. So what does common sense tell you have to do with that equation? Integrate, specifically from 7 to 14. Is there an initial condition I have to worry about? No. Okay, it's literally just pay attention to the units and you've got your answer right in front of you. Okay, anytime you lose a rate, you're taking an integral. Anytime you add it on, you're taking a derivative. 28. A particle moves along the x-axis given its velocity is this. The position is 3 at t equals 0. So again, there's that initial condition. what is the position when the velocity is first equal to 0? So do I know what the position is right off the bat? No, I have to figure that out first. What is the position when the velocity first equals 0? So the first thing I want to do is set my velocity equal to 0. And again, it's graphing. You're solving this graphically. Throw that in your y equals and find when the velocity first hits 0. 0.655. 0.655, so verify that. Throw that in your calculator. I think you're right there.
I know how to use my
Good, good. So again, you're going to graph it. You're going to see when it hits 0. The first time, it hit 0 a lot, but the first time is what we're looking for. Use that 0 feature. Now it wants the position at that time. So I want the position at that 0.6, did you say 55?
Yeah.
Has to equal the position at what time? 0. Plus the integral, those should be the same from 0 to what I want, 0.655 of v of t dt. And then you've got your answer. I think so. I think that's what I had. Okay. All right, so great timing. We've killed the first fundamental theorem. Tomorrow we're going to focus on the second. Your only homework tonight is to finish those test corrections. We want the entire packet done. So you got test corrections. Hopefully you don't have a spiral lingering around still. Otherwise you got double the work there. I just have to print the new spiral. I'm going to do that next period if you're looking to get a head start on that, but I will print that out and it will be ready to go. So bring this back tomorrow. We're going to tackle the second fundamental big time.